Welcome to week 14, set 1, SWYK 1. Glad to have you back, folks. I know you're saying the exact same thing. Let's look at what we're talking about this week. Factoring. Talking about the greatest common factor. Sometimes it's not just a number, sometimes it's not just a variable, sometimes it's more than that. For instance, in this, not only does every single term have oops, I better use the other one. Every single term have a 3 in it, right? You can go through every one of those and take out a 3. They also have x cubed, not just x or x squared, but they have x cubed. So basically what you're doing, and let me zoom in here a little bit. When you say factoring, remember, that's a word for division. You're basically going through and you're dividing out all of these by 3x cubed every time you do that. And then you look at what's remaining. So we have the 3x to the third on the outside, and then as you go through, you'll see that your first division ends up being 5x squared, and the second one is minus 3x, and the last one is a plus 4. So that is the only thing you can do with this. I know, because I double checked. I said to myself, hey self, why don't you find the old discriminant? Remember that thing, the discriminant? B squared minus 4ac. Sorry, that does not look like b squared minus 4ac. Right, so I did that right down here at the bottom. Looks like I got a negative number, negative 71. Yeah, it's going to give me imaginary numbers. That's not going to be... It needs to be a positive perfect square if you're going to be able to factor it anymore, but you can't. So that's as good as it gets. Okay, so on to the next one. Question 2. What if the factor is a negative? So we can have that situation occur. So, and typically, if I'm going to take a negative 8 out of these terms, what's that going to do to the first term? It's going to make it positive, right? Positive x. It's going to make the second one negative 9. This trick happens a bunch in Algebra 2 and then pre-calc. And that's how you can end up getting things to flip around. Sometimes they'll do things like 72 minus 8x. Well, guess what? That's just fancy talk for what you have over here. And so to take care of that, you will pull out a negative number and then flip things around. Then the factor looks normal, x minus 9, instead of negative 9 plus x. Okay, so what about the next one? This next one has a negative 2 in it. And did I do the discriminant on this one? I thought I did. Whoa! Pause for station identification so I can check and see if I can factor any more. Alright, I did the discriminant. B squared minus 4ac. I got 97. That's not a positive perfect square. We're all good. Now, besides that, they said in the instructions, factor out the negative coefficient. So they didn't say something like factor completely. That kind of thing. Okay, factor the following polynomial. As you can see, a little bit more involved, more things going on here. This one involves a process called, let me write it down for you, chunking. I know, completely technical math term, but that's what it is. That's what they call it. It's what you're basically looking at are taking the first two terms and the second two terms and kind of separating them. And you look at them and say, okay, out of these first two terms, what's the GCF? Well, you can see out of the first two terms, you can take out an x squared, so I did that. That left me x plus 8. Then I looked at the second two terms, and I said, well, what can I pull out of those? And I pulled out a 4. That left me x plus 8. Now, the key to this concept of chunking is the fact that when you pulled out what you did from the first two terms and the second two terms, you were left with the same thing. You notice that I got x plus 8 both times. Okay? So now what they're doing is this. Now they're using the basically they're using a GCF again. And they're saying, what does this term and this term have in common? Well, they both have an x plus 8. So if you pull that out, what are you left with? Well, the two things in green that I circled, x squared and plus 4. So you'll see that my final answer looks like this. Now, does it matter whether you put the x squared plus 4 before the x plus 8? No, it does not. Completely up to you. Oh, sorry for yawning. I know you guys hate it when I do that. Anyway, so that's your final answer. This is called chunking. The next particular one that we're dealing with is called a sum or difference of cubes. Now, I've tried to write out the formula. So here's the formula as a sum of cubes. A cubed plus b cubed. Now, I want you to follow a pattern with me. First, I take the cube root. So that you're going to have a linear factor. Okay. Oops, I do not have enough room here. Let me pause. As I was saying, a linear factor, and then what is called a non-factorable quadratic. I know that I kind of wrote real small there, kind of crammed everything in from one problem to the next. So, in other words, the second part, the quadratic on the second part, is not factorable. So, what we did to go from the first term to the first part of the linear factor was we took a cube root. Okay, and then we're going to do the same thing here. We're going to take the cube root. And then this sign right here matches the linear factor. Okay, now to go to the next part, we are going to take this one and square it. Because really, when you multiply those two things together, you're supposed to get a cubed. Okay, the first term. And then you're going to take this term and square it to get the last term of. This is the, how do I find the non-factorable quadratic? The pattern also goes on to say that then you multiply these two things together and take the opposite sign. The opposite sign. And if I go over here and look at this other one, here is the same type of sum or different. This is a difference of cubes, right? But let me walk through. Cube root. Cube root. Same sign for the linear factor. Square it. Square it. Multiply them together, take the opposite sign. Works exactly the same way, just for the difference. So those are called sum or differences of cubes. Okay, so now we're going to use that pattern in question 5 here. So we have a sum of cubes to start with here, right? X cubed plus 125. So if I take the cube root of x cubed, I get x. Take the cube root of 125, I get 5. And I take the exact same sign in between. Then I square the first term, square the last term, multiply the two terms together, and take the opposite sign. Now, how do I finish the rest of this question? Because I'm supposed to solve this thing. Well, the first one's pretty easy, right? Yeah, set it equal to 0, it's solved, right? X plus 5 equals 0. Subtract 5, you're done. Second one, not as easy, right? Because you do have to set it equal to 0, right? You set that thing equal to 0. Well, the only way you're going to do that is with the quadratic formula. So, back to the drawing board. Remember, discriminant, b squared minus 4ac. Well, I did that. I got negative 75. So that means I'm going to get imaginary numbers, right? So then I do the second part of the quadratic formula. Opposite of b, remember it's the opposite of b, plus and minus, square root of, slide your discriminant in there, all over 2 times a. Okay. Now the square root of negative 75 can be broken up into the square root of negative 25 and radical 3. Remember that the square root of negative 25, that is, dun dun dun, remember that's 5i. 5i. Because the square root of negative 1, remember that's the I part. Okay, so I can rewrite this as 5 over 2 plus or minus 5i radical 3 over 2. Which, if you take those answers and those answers, leads you to letter D. Do look at the way they wrote them. See, notice how I wrote 5i radical 3. They wrote 5 radical 3 over 2. They put their I on the outside like that. Big deal. It's still the same thing. As long as you know that the I is not in the radical, you're good. Okay, question 6, another type of question like this one. Sorry we're going long on this video. But we're doing the exact same process. we got the cube root, same sign for the linear part. Set that thing equal to 0, and you got 10 for the answer. And then you square it, multiply them together, and take the opposite sign. Okay, that part gets set equal to 0 also, and you do the whole quadratic formula thing, right? B squared minus 4AC, that gives you negative 300, which can be broken apart into the square root of negative 103. Okay, we have the opposite of B, plus or minus the square root of negative 300, which is really 10I. Remember that thing right there is the 10I. And then the radical 3. Notice how we simplified them. I broke it up. I always break it up into 2 parts because you guys reduce it much easier if you break it up into 2 parts. If you try to do it all in one, you know, bad things happen. So negative 10 over 2, that gave me the negative 5, and then the 10 and 2 cancel out in the second one as well. So all of these things lead me to letter choice A. Last question here for this SWYK. Find the real or imaginary solutions. This is called a hidden quadratic. This is, should have labeled it, but I didn't. Hidden quadratic. So, first you don't think it's a quadratic, but it is. It's just that instead of x and x, you start off with x squared and x squared. You'll notice that I did take the negative 64 and move it to the other side, set it equal to 0. But then I'm just doing my same old factoring, right? Well, multiplies together to give me positive 64, but adds up to negative 65. Well, and so I did negative 64 and negative 1. But then I noticed they're both differences of perfect squares. So I was able to break this one down into x plus 8, x minus 8, and this x plus 1, x minus 1. And then, of course, we set all the factors equal to 0. Remember that? And once we do that, then we end up with these answers. Now, I think based on the instructions I see here in Math Excel, they want you to write something like this. I wish they'd just leave you do the plus and minus since you have both of them, but picky. All right, see you in the next SWYK.